Good morning everyone. So the topic for today's lecture is bonding. So if we talk about the definition, what the bonding means to, it is derived from the Latin word which means the adhere. That means to stick to. So it is the state in which the two surfaces are held together by the interfacial forces, which may consist of Valenic forces or interlocking forces or the both. So basically what we are doing, we are talking about the bonded restorations here. That means these restorations are bonded to the tooth. So for bonding them to the tooth, we need certain kind of agents. So they are known as the bonding agents. So here the bonding is happening between the bonding agent and the enamel or the dentine. So what is this bonding agent here? It is an adhesive which is a viscous fluid-like material that joins the two substrates together and solidifies and therefore is able to transfer the load from one surface to the other. So here if we see in this diagram, here there is adherent one, which is your enamel or the dentine, and the restoration which is being adhered, and in between you have this adhesive, that is your bonding agent. So adherent one is your tooth structure, the adherent two is your restoration, and in between the bonding agent which acts as a adhesive here. So which all cases we can go for these bonded restorations? Definitely for all types of class 1, 2, 3, 4, 5 and 6 caries defects. In all these cases we can use the bonded restorations. Then where you have to change the shape and the color of the anterior tooth, like for example cases of fluorosis. So in mild fluorotic cases you can go for the direct composite restorations. For that you again need those bonding agents. Then to bond the all ceramic restorations and the crowns. Then to bond the fractured fragments. For example, if there is a trauma to the anterior tooth and the segment or any posterior tooth also, and the fragment of the tooth gets fractured, so these two fragments can be joined or they can be bonded together with the help of these bonding agents. Then to repair the existing restorations, already if a restoration is being done and you want to do any kind of repair, then this can be used. To seal the pits and fissures, desensitize the exposed root surfaces, because these bonding agents can occlude the dentinal tubules, thus reducing the sensitivity in cases where there is exposed dentinal tubules or where there is recession and the root surface is exposed. Then to bond the orthodontic brackets also you do use these composite restorations with the help of the bonding agents. Now talking about the types of adhesion. So basically the adhesion is mechanical, chemical and the physical. If we talk about the chemical, so it happens either with the help of the adsorption or diffusion, and physical with the help of the electrostatic. So first we'll talk about the enamel adhesion or the enamel bonding. So if you have seen while painting the walls, what we do, we have to roughen the wall surface and then prime the wall surface before we apply the paint. And what happens when we do this roughening and priming of the wall? The paint will stick better to the wall. That is the purpose. So similarly, we want that a high strength and a good bonding occurs between the tooth and the restoration. So we have to prepare the tooth surface, and that preparation of the tooth surface is known as the acid etching or the conditioning of the enamel. And this concept was first introduced in 1955 by Bunocore. So what is this acid etching? It is the process of roughening a solid surface, which is your enamel here, by exposing it to an acid and thoroughly rinsing the residue to promote the micromechanical bonding of an adhesive to the surface. So what kind of bonding we are achieving here is the micromechanical. Why micromechanical? Because the roughening has been induced now. So that leads to a very good bonding between the enamel and the adhesive agent. This acid etching, it will transforms the smooth enamel into irregular surface and increases its surface free energy. So when a fluid resin based material is applied to the irregular edge surface, the resin penetrates into the surface aided by the capillary action. So what is happening? आपने surface को roughen किया, and when the surface is roughened, the adhesive which will you apply now, it will go into those, it will flow into those roughness. So this is something like this, if we see in this picture here. So this is the enamel surface, आपने roughen किया, then you apply this adhesive layer and this is going inside those roughness and the tags are being formed. So these tags are known as the resin tags. These are the resin tags. These are the micro tags and these are the macro tags. So this is how a very good bonding occurs with the enamel. And for this purpose, that is for the etching, the agents or the acids which are being used is, the commonly used is a 37% phosphoric acid, and other acids which have been tried, that is 10% malic acid, 2.5% nitric acid, and the time duration is 15 seconds. And the various enamel bonding agents which are available, they contain this dilute bis GMA or Tec DMA resins. And this bond which is happening here is a hydrophobic bond, because this material, this bis GMA or Tec DMA resin, they are hydrophobic. So we have to make sure that enamel is completely dry when you apply these adhesive layers. And there are mainly three types of etching, enamel etching occurs. The type 1 is the core etching. That is, here the core gets dissolved while the peripheries remain the intact. So it gives a honeycomb appearance. The next is the peripheral etching. That means the core is remaining intact and the periphery is getting dissolved. And the third is a mixed pattern. So somewhere the periphery is getting dissolved and somewhere the core is getting dissolved. Now coming to dentine bonding. Earlier we discussed was the enamel bonding. Now the dentine bonding. Dentine bonding is considered more difficult than the enamel bonding. Reason being the water content. The dentine has a greater water content. It has a greater organic content. It makes it hydrophilic, and as I mentioned that resins which we're using, they are hydrophobic. So since it is hydrophilic, it has more water content, so it becomes very difficult to get a good bond with the dentine as compared to the enamel. And yes, the dentinal tubules which are present, they contain the processes of the pulp, the odontoblast. This is what the dentine structure is. It's all dentinal tubule, so this all makes it very difficult. Then presence of the smear layer. What is a smear layer? When you make a cavity preparation, so the debris, the organic debris, whatever the debris is getting collected, they occlude the dentinal tubules and they form what are known as smear plugs. Here you can see this is what is known as a smear plug. So whenever a tooth structure is prepared with the burr or other instrument, there is a residual organic and inorganic components which form a smear layer of debris, and they fill the orifices of the dentinal tubules and they form a smear plug. So these smear plug, because of these smear plugs, the bonding also becomes difficult when it comes to the dentine. And this smear layer was first introduced by Boyder et al. In 1963. The thickness of the smear layer could vary from 0.5 to 5, and because of this the dentine permeability is reduced. So this is what the concept of the dentine bonding agent is, that now dentine is a hydrophobic one, the material what you are using is a hydrophobic, and so you need a dentine bonding agent which has both the ends, a hydrophilic end which can bond to the dentine and a hydrophobic end which can bond to the composite. So you need to have the modification of the bonding agents which were being used. So there has been like lot many generations which has come up. Like there are first generation, second generation, third generation, from first to 8th generation, different generation of dentine bonding agents are available in the market, and these dentine bonding agents they show different strength. Then they utilize like some are hydrophilic, some are hydrophobic. So over the time the evolution has done in the content of these dentine bonding agents and how well they can establish the bond with the enamel or the dentine. Basically the dentine bonding have evolved through these generations. So talking about the first generation, in the first generation the smear layer was not considered, and it achieved the deeper penetration into the dentinal tubules. And the mechanism was they were bonded to the enamel and dentine by chelation with the calcium. That is how they were being bonded, and they included these, the NPG GMA, that is N-phenyl glycine glycidyl methacrylate. So these were being used, and this is a bifunctional molecule. That means it can bond to the dentine while the other end polymerizes to the composites. So this was the first generation dentine bonding agent, but the disadvantage was that there was a low bond strength of only 2 to 3 megapascals, and the bond strength was lost over the time. They lacked the stability of the individual components. So because to overcome this, the second generation was introduced. This is how the evolution has been done. Now the second generation was the clear fill bond system F, which was first introduced in Japan in 1978, and it is comprised of the phosphate ester material. The mechanism, the earlier was the chelating action. Now here the mechanism was the interaction between the negatively charged phosphate group of resin and the positively charged calcium in the smear layer. In the first generation, the smear layer was ignored. Now here it is forming a bond with the smear layer. And some of the examples are the Scotch bond by 3M ESP, Bond Light by Kerr, Prisma Universal by Dentsply. Now, since they were bonding to the smear layer, and smear layer is not it's not something you can say a strong structure. So bonding is occurring with the smear layer. So this was the weakest link. In the previous one, strength was compromised. Here, the smear layer was the weakest link in the system because of relatively loose attachment. Yes, it is loosely attached to the tooth surface, and something is bonded to a loose structure, so definitely it is a weak point. It cannot comprise, or it cannot have a good strength what we want to achieve. So bond strength here was also very low, that is around 1 to 5 megapascals. Then third generation. It was introduced in 1979, and these were designed not to remove the entire smear layer but rather to modify. Earlier we were using the smear layer, now to modify. And what we were doing, it involves the concept of phosphoric acid etching before application of the phosphate ester type of bonding agent. Here, since there was a modification, so bond strength was improved, that is around 8 to 15 megapascals, and the example is like the Scotch bond 2. But yes, the limitations remain. The pulpal inflammatory responses were thought to be triggered due to the application of acid. So this is how we are saying that in one generation some or the other problem is there, so we are overcoming it with the next generation. So there are n number of other generations also. So today it's time, we should finish with it here only. So the next from 4 to 8 generation we'll be discussing in the next classes. That's all for today. Thank you.